Hello, today I would like to cover this portion called completing the square for A-maths. Let's take a look at this question whereby it says to state the maximum or minimum value of each of the following and the corresponding value of x. So there are a few things to take note of. One is to know whether the expression is minimum or maximum. That's the first thing we need to know. Second thing we need to know is to find the value of its minimum or maximum point. The third thing that we need to know is the corresponding value of x. So there are three parts to every question. Now, how do we find out whether an expression has a minimum or maximum value? We will have to look at the coefficient of the x squared term. So if you were to take a look at questions A, B, C, and D, for A, if you look, this x is over here. If we were to expand out this entire expression, the x squared term will look like that. It will look like this. And the coefficient is 1, which is more than 0. Now, when the coefficient is more than 0, it will be a minimum value. So that's for A. If we were to take a look at B, B says x squared minus x squared plus 9. Straight away, we can tell what the coefficient of the x squared term is. There's a minus sign there, so the coefficient is -1, which is less than 0. Hence, this will give a maximum value. So this, using examples A and examples B, we are able to tell whether the expression has a minimum or a maximum value. I believe for C and for D, when you expand out the expression, you will be able to tell whether the expression is a minimum or a maximum. Now, let's move on to how to find the value of the minimum or the maximum point. To find the minimum or the maximum point, perhaps let's take a look at one of the examples then. Okay, that might be easier when we assign values to it. Let's say if we were to look at x minus 3 squared plus 5. Okay, that's for question A, right? We know that it offers a minimum value. Now, when is this expression minimum? It is minimum when you put in a certain value of x and the entire expression would give the lowest possible answer. Okay, so I'm going to put this down. This expression is minimum when we put a certain value of x such that the expression gives its lowest value. Okay, now let's see. When would this be its lowest value? How can we make this value as low as we want to? You see a square there? Yeah, this is a squared number, a squared value. Anything that is squared would have a minimum of 0. Now, how can we make whatever that is within the bracket 0? To make whatever that is within the bracket 0, that would make x minus 3 be 0. Therefore, x would be 3. Okay, now let's replace the x by 3. So when we put the value of x equals to 3 into here, okay, you will notice that 3 minus 3 square gives you 0 square, which is 0. Now, any number that is squared would be either 0 or something that is positive. Even if it's a negative number within the bracket, when you square it, it will end up positive. So the minimum value of x minus 3 whole thing square is 0. It cannot go bigger than that. Now, next, let's take a look at the plus 5. Plus 5 is a single value. It is an absolute value. It does not vary because there is no value, there is no x in there. So plus 5 merely means 5. Okay, now let's combine both together. What is the value of x that we can place in here that would give its minimum? 0, right? So let's say the first portion here, x minus 3 whole thing square, ends up as 0. This entire thing ends up as 0. Okay, now I'm going to copy down the next portion, plus 5. Now, this would give us the minimum value of the expression. So the minimum value is 5. What would then be the corresponding value of x? Corresponding value of x is the x value such that when we insert it into the expression x minus 3 whole thing square is equals to 0. So what is that value? Just now we have just worked it out. That value itself is 3. Therefore, x equals to 3. And 5 is in turn the minimum value. If I were to summarize what I have just done just now, let me use a little space over here. Given an expression in the form where the square has been completed, the minimum value would be taken from here. This is the minimum value. Okay. Now, what about the corresponding x value? The corresponding x value would be this entire expression here equating it to 0. So when we equate x minus 3 to 0, we get x equals to 3. This would be the corresponding x value. Subsequently, if we were to look at questions C and questions D, okay, if we look at C itself, the square has been completed. What would be the minimum value? The minimum value will be here. And to find the corresponding x, we will let this be 0. When we let x plus 4 be equals to 0, x equals to minus 4, this will be the corresponding value of x. Now let's take a look at D. When we multiply the expression out, when we expand it out, our value of x squared, the coefficient, is negative. This would give us a maximum value. Okay, in this case, a is negative, so we will have a maximum value. What is the maximum value? Our maximum value will be this. What is the corresponding value of x? Look at what is within the brackets. Equate it to 0. From there, we will get our value of x. This would be our corresponding value of x. Next, moving on, find the maximum or minimum value of each of the following and the corresponding value of x. So you realize that these questions here are very similar in terms of instruction to the previous one. The only difference is that for question 2 here and question 3 is written in ax squared plus bx plus c. Yeah, okay, so this is in the form ax squared plus bx plus c. Yeah? Whereas the previous page, everything a, b, c, d is in the form where the square has been completed. So one extra step, complete the square first. Okay, so let's take a look at question 3D. I will leave questions A, B, and C out. We'll just focus on D. All the methods are the same. So for D, this is the question. Let's rearrange this according to ax squared plus bx plus c. Okay, now we complete the square. You realize that the coefficient of x squared is not 1. How do we make it 1? Now we have to make it 1 by factorizing 0.2 out. So when we factorize 0.2 out, what we are left with is this. Okay, we got to factorize 0.2 out of minus 6. So we take minus 6 divided by minus 2. So what we end up with is 30 plus 30 x, and I'm going to leave 7 out, okay? Because when we complete the square, what we essentially need is the first 2 terms of the expression. From there, we force it into a square, create 3 terms, take away the last term. Okay, now take out 0.2. Now we're going to complete the square for this portion. Okay, so I'll put a little note here. We complete the square here only. Okay, so what's next is x squared. We drop the square, becomes x. Second term, we halve the 30, drop the x square. Now, by doing this, what we have done is we would have created a plus b whole thing square. Okay, now a plus b whole thing square, we expand it out into this. You realize that the first two terms is the first two terms that we have here. Yeah. However, when we force it into a square, we create a third term which we don't need. This is the extra term that we don't need. Let's take it away. This is 15 square. So we take away 15 square and we plus 7 on the outside. Okay, now let's continue. Wait, I think I made a little mistake here. I should not have minus 15 square minus 15 square. Okay, the square is inside because I want to take my 0.2 multiply by the minus 15 square minus 0.2 minus 15 square. Okay, I'll get 45 plus 7 minus 0.2 x plus 15 square plus 52. So from here, I will have completed the square. Again, how do I find whether it's maximum or minimum value? Let's take a look at the x square term first. So, hey, our x square coefficient is negative. So therefore, this tells us that it is a maximum. Okay, next, we want to find the value of the maximum. This is the one. This would be the max value. And the corresponding value of x, I take it from here, equate it to 0, and from there it implies that x is equal to minus 15. So from this example, we can actually see and pick out where in our working we can answer the questions that are being asked. Next, let's take a look at question 4 together. Show that the expression x squared plus 4x minus 3 is more than or equals to minus 7 for all real values of x. Okay. And I think by now, we want to see that, hey, just the expression x squared plus 4x minus 3 doesn't quite tell us anything. Okay. Why not let's complete the square and see what we can figure out from there. So x squared plus 4x minus 3. Let's complete the square. So we drop the x. 4x, we have it, and we drop the x as well. We will have created a third term. We take away 2 square and minus 3. X plus 2 whole thing square minus 4 minus 3. X plus 2 square minus 7. Okay. Now, how can we show this is more than or equals to 7? What I'm going to do next is I'm going to break this expression into two parts. This is the first portion over here. Let's try to analyze it. Okay, now we have x plus 2 whole thing squared. When we put in any value of x, what happens to the value that it produces? Let's say real value, right? So if I were to put in x equals to 1, okay, then I'll have 1 plus 2 whole thing squared Oh, that gives me 9. That's more than 0. If I have x equals to minus 1, I have minus 1 plus 2 whole thing square, and therefore it is 1 square, so 1 or more than 0. What if I put in a value where x is equals to minus 2? Now, if x is equals to minus 2, I have minus 2 plus 2 whole thing square. Oh, 0. All right. I will figure out that with a square over here, whatever that is within the brackets, as long as it is not 0, when I square it, it will be given a value that is more than 0. Okay, hence I have one case whereby when I put in any real value of x, my answer will be more than 0. My second case is that if I were to put in x equals to negative 2, whatever that's within the bracket will be 0, and it will give me a value of 0. Therefore, okay, we could say that x plus 2 whole thing square will give you an answer of more than 0 or 0 for all real values of x. Now, with this understanding, I'm going to write down I am going to add something to both sides of the inequality. I'm going to add in a minus 7. Remember, just now we were just trying to unpack what's x plus 2 bracket square. Now I'm going to bring in the negative 7, which we have not unpacked yet. So when I bring the negative 7, I want to put it here, right? So that it will look like the original expression that we are given. I mean, that's fair, isn't it? So I'm going to bring in this. When I bring in this, I'm putting the negative 7 on the left hand side of the inequality. I need to equate it to the other side of the inequality as well. I need to put it there as well. So right hand side also doubles up with a negative 7. And therefore, we can say very confidently now that x plus 2 square minus 7 is more than or equals to, now right hand side, if we simplify, we'll get negative 7. What is x plus 2 square minus 7? This entire expression over here, isn't it this expression we have over here? Yes. Isn't it this expression over here? So therefore, we can say that x squared plus 4x minus 3 is more than or equals to negative 7 for all real values of x. And we have shown it. So I hope that through this short explanation, you're able to better understand the lesson today.